Hi. So, the QA lecture that's coming up, I made that over 7 years ago, probably over 10 years ago. I can't exactly remember when I did it. However, after having worked in quite a lot of companies, on a side note, I should mention that QA is often done differently by different departments and in different companies. Some have adopted a much more manual approach, some have migrated a lot more to um, automation of testing, and the amount of detail that they require in order to test things tends to vary at different stages based on the company. So this was just one way I saw it done. This was my experience working at a large insurance company in the States in the past. However, I don't think that going to so much detail with QA is always a good idea, since oftentimes developers catch their own issues as they develop and work with the data, especially with regards to databases. And that sometimes is a lot faster than having someone test the software as was done at this company, or test the database logic as it's being developed. So I don't actually think that's a good idea. I think that a lot of things should be left, it should be more fluid, and by being more flexible with your approach and tailoring it towards how the developer feels most comfortable working, I think that you will have a lot more progress and success with your systems. By having someone testing in parallel with the developer developing, it introduces a whole new set of problems because their attention won't be focused. So yeah, so now let's get on to the lecture on, and I believe, if I remember correctly, I haven't watched it since I made it, but I believe this was focusing mainly on manual efforts. So yeah, get ready for it and let's go.
To test your system. It's a general document, so you don't go into much detail. So basically, in the test strategy, you'll discuss the scope and objective of your project, the roles and responsibilities of the different people in the project, the higher level people, the business issues that may arise. You want to see, uh, describe the deliverables and approach, any tools that will be used, risks, how you're going to report them, training plan for the new people that are going to come onto the team. It's basically a strategy. You're thinking about how you will approach the monumental task of testing a system. Next document that is made is after creating a test strategy and having figured out all the higher level details, is a test plan. The test plan is made by the team lead, and it goes into a little bit more detail than the test strategy did. Uh, so what the test plan does is basically allocates the responsibilities to different members on the team, not just the higher level members. It talks about what's deliverable, the features that you're not going to test, the testing tasks, the criteria for passing or failing, the features you want to test, your approaches, it'll go into more detail with staff and training needs. It'll talk about the schedule, um, and it will have all the little details. This is a general a guideline. So often, while test plans and test strategies may exist, sometimes this varies from company to company. So sometimes they might have a general document that is both a test plan and a test strategy, or sometimes they may be so unorganized they might not even have that, just expect you to know what to do. I've seen situations like that. So sometimes they don't even have this. They'll just expect you to implement test cases and stuff because they haven't structured everything correctly. However, I think it's a good idea to follow these sort of document structures because it helps you do proper testing. And um, while everyone can program and everyone can test, not everyone can do it correctly. And this is what is meant by this. this is the reason for these documents and why these approaches have been standardized. Okay, so then you will have a mapping document created. The mapping document is often created while designing the database. Mapping documents are made when you have, for example, two different databases like OLTP, and you'll have your staging database, and then you have your staging database and your OLAP, right? What the mapping document does is says which columns in the OLTP will be pulled from, and where they will be loaded, and the columns they will be loaded into in the staging tables. So basically what a mapping document says is where do the particular columns in a table get its values from, and what are the transformations the data goes through in order for it to be loaded there. So it's often in an Excel spreadsheet, but once you look at the Excel spreadsheet and sort of think about it, you should be able to intuitively figure out what it means. If not, you can just always Google it, and you will get a more detailed explanation. And next in line after having a mapping document, the mapping document is normally made by the BA of the team or the business analyst, right? From that, you will have a traceability matrix. In traceability matrix, you will have which is also made by the business analyst. It's also in an Excel spreadsheet a lot of the times. It's going to tell about the functional, about the business requirements of a system and how they map to functional requirements for that system. And then we get along to test cases. The test cases are often based off the traceability matrix and the mapping documents, because normally when you're testing a database system, often you don't have to actually look at the code, right? So in order to do this, you will look at that, and then you will start writing test cases for the ETL or the column mappings. So you'll test to ensure that the mappings were implemented correctly. You'll test the functionality of the stored procedures. You'll write tests for that. And everything else. Basically, as the definition says in the slide, it is the mechanism for determining whether a software system or software program has passed or failed, right? So basically, you're finding the weaknesses and you're trying to break that system by writing test cases that will work. The ultimate goal of I often like to think of the QA team as a bunch of hackers because they had to find the weaknesses in a program. And what else do hackers do but find out weaknesses and exploit them? Except as the QA team, you don't exploit them, right? Your job is just to find them. So right here I gave you a test case example, because sometimes it's difficult to conceptualize it in your head. I could say an Excel spreadsheet, but you're not going to just automatically know what they mean. So if you look at the spreadsheet right over here, you'll see that it says features to test in one of the columns, execution values, execution steps, and expected results. So basically the main components of this test case is what are you testing for the test case, right? In this test case, which is not a test case for a database, it's a test case for a system login. It says the features to test is, let's look at the first one. It says minimum password size, right? So it's going to tell you the steps you have to go through in order to test that particular case. So here it's going to say the first step you got to do to test whether the minimum password size constraint is set is create a new, click the create new user button, add a password with 5 symbols, fill in all obligatory fields, create a select create user button, create new user button, add password with 6 symbols, fill in all the other obligatory fields, select create user button. So this is actually 2 tests in one. The first part of the test, which is 1 through 4, tells you what it expects. Since the minimum password size should be 6, the first step will not work. So a new user will not be created. by creating a password with 5 symbols. So you'll get an error message, and it'll say that you had to create it. The username should be corrected. So in the next test, since you created a password with 6 symbols, which is the required number of symbols, the username will pass the validation and a new user will be created. So that's basically a test case, right? It's as simple as you think it is, and that's exactly what you're supposed to do to test the program. In the case of database, you'd probably put in the SQL for a query in order to test it, since you're working with the database system and not a UI or a user interface. You often use queries to test the database. Okay, so now we get along to what is a test script. So we have all these test cases on what you should do, and then what is a test script? A test script in software testing is a set of instructions that will be performed on the system under a test to test that the system functions as expected. So in the case of database testing, your test script is going to be your SQL query that you're using to test the system. So now I'm going to teach you how to write proper test scripts and test cases that cover most of the scenarios for a relational database table. In this, I actually used Microsoft SQL Server and AdventureWorks database as sort of it was the AdventureWorks database without any alterations. I'm going to use that to explain it to you. So when you're creating the test cases, this is when you're implementing them and putting them down on the Excel document. You have to realize that it's an art. If you don't create these test cases properly, they're going to have repercussions down the road, and by letting through bugs, you're going to have problems. So if you do it properly, you should let through as little bugs as possible. The more situations you test, the better. You have to be as tedious and pay as much attention to detail as you can, because it is it's a very important thing, and it's always in the details that you find out the problems. There are normally, when I design test cases, I normally test these main categories. I will test the surrogate key constraints to see if it's right. I normally write SQL queries to do that, because a lot of times, well, not a lot of times, but sometimes you're going to meet a developer, and they're going to be implementing these tables as the data modeler described them, and then they're going to forget to implement these constraints. I know it sounds crazy, but it happens. So they're not going to put a surrogate key constraint on like a particular column. They're going to make it an identity column, or they're gonna miss for a column, they're going to put the wrong data type, so it's not going to be a particular data type. They're not going to have any referential integrity maintained, so you'll have foreign keys that are not pointing properly because they didn't implement a foreign key constraint. I know it sounds crazy, but I've seen it happen. You're going to have derived and calculated values that are not correct. You're going to have the business rules being implemented incorrectly, or you're going to have the requirements of the system, even though the BA put them down, they're going to be wrong. They're going to be wrongly implemented. There's so many things that can go wrong, or the ETL is going to be wrong. They're gonna have bad masking or encryption on a particular column. So like your password column, they're going to say it's encrypted. It's not going to be encrypted. Or they're going to want to use a view to protect the data, but they're not going to use that view. Or the incremental loads won't even work. There's so many things that can happen, but these are the major categories, and I think these are a good starting point in order to capture and encompass most of the problems that might occur. So here are some examples of created test scripts. Okay, I based this on the AdventureWorks database again. Okay, so surrogate key, check. So what is it about a surrogate key, right? A surrogate key, this is a simple check. I'm pretty sure you can go into more detail if you wish to. What I like to do is make sure that there's not more than one a column with the same value in a surrogate column, right? Because one of the constraints is that each and every column entry is unique. So I use a select statement. I group it by the contact ID, right? and I check to see whether there's more than one contact ID with the same value. So if there is, it's going to display. If there isn't, and the actual query works, it will not return anything. So that will, for that particular column that you're testing, that will pass it, and that will ensure to you that it works as you think it did. That's the asserter key check I often use. Here's another check in SQL Server. When I'm checking the column integrity, in order to determine whether the table was implemented properly, I like in the mapping document. So in your mapping document, you're also going to have the columns and their data type. So this is a query I often use. Here I query the sys.columns table. I use type underscore name to find out the type of column it is. So whether it's supposed to be an int, nvar char, or a name column or a phone column, and then I'll only return the columns that don't match the mapping specifications. In the case of this document, my mapping document for AdventureWorks, it said that the contact ID column was supposed to have a type of int. Email address was supposed to be nvarchar. First name was supposed to be name. I made an error there on purpose. Last name is supposed to be of type name, and phone is supposed to be of type phone. So now let's go over to SQL Server and check how that worked. Right? Remember, I made this is supposed to be a name variable, and that is actually implemented as a name variable, but I said the wrong type for this. So it's going to only return one row. So I ran it, and there you go. Because the column name first name is not a vname column type, it's a name column type. So just look at the code for a second if you didn't understand what I was trying to say, and you should be able to get it pretty quickly.